In question 2, this is a question about electric circuits. First off, you need to spot 3 errors in the student circuit. So the 3 errors are: the ammeter is in parallel instead of series, the voltmeter is in series, this should be in parallel, so basically the 2 meters should swap, and the third one is the cells are arranged so they cancel each other out, and so there's no voltage in this circuit. In part B, you needed to graph the following data. You would find the graph grid over the page. Here it didn't matter if you put voltage here on the x-axis or on the y-axis here. I'm going to label this graph with the voltage on the x-axis and the current on the y-axis. So 1 mark for getting the quantity, in this case the voltage, with its correct unit of V for volts, and current with its correct unit for amps, capital A. As you can see, you can label your axes. You've got to enable your axes so that you use half of the graph, the grid, to get the mark for scaling and using the graph paper. More than half the graph paper needs to be used. And here, if you look at the plots that you plotted, it isn't a straight line. This relationship is actually a curve. So you need to draw a smooth curved line. This is incredibly tricky. This has actually been my 3rd attempt trying to draw on the screen, and as you can see, the first bit is actually linear here, and then it starts to curve here. So you have 1 mark for getting your quantities and units, 1 mark for getting your scaling right and using more than half of the graph paper or graph grid, and 2 marks for plotting your points correctly, and the 5th and final mark for your line of best fit. Next, for the second part of this question, you need to use your graph to find the current. So you use your graph, you are looking at when the voltage is 2.4, so you're going from 2.4 up here, and where it hits the line is where you read off. And actually here you can see I've got a mistake in my line of best fit, how I drew it. So actually my 2.4 volts should give me a reading of 0.4 amps. You would get a mark if you got a range of between 0.39 amps to 0.41 amps. There's no mark for the unit here, but if you consistently put units with your answers, you will always get your marks. There's 2 ways of saying why the line on the graph curves. The first one is the temperature of the wire was not constant, and the second, expressed a different way, is the resistance of the wire was not constant. This part 4 was badly answered by some students, with only 1 mark being scored. I think one of the easiest answers to give in these accurate value, now accurate value means the true value, is to put down, repeat your readings and take an average. The next idea was, how do you keep the temperature of the wire constant? If you just say constant temperature, it's mentioned in the question, so you won't get a mark. You need to actually give how you're going to do this. So one idea is to use a switch. You use the switch, you turn the current off and on, and only let the current flow for a short amount of time. Now, using the equation V equals IR, you have V is proportional to I, and therefore you would only use the straight part of the graph when you're calculating your resistance. Another way of improving the accuracy of your value for your answer is to take more readings, but take more readings at different values. So here the idea is to take more readings, so maybe at 1 volt, 2 or 3 volts here, 5 volts here. So the idea is to put extra readings between the voltages that you've recorded already. And as mentioned before, you use the gradient of your graph to find the resistance. And the final mark is for giving an instrument to measure the temperature of the wire to make sure it is kept constant. So I suggest here a digital thermometer. So there's 4 marks here. So there was 1 mark for repeat readings and average. There was a 2nd mark for using a switch to ensure that the wire cooled down between your readings. And this point here is a 2-mark point. So the first mark is for V equals EIR, the fact that voltage is proportional to current. And the 2nd mark is when the temperature is constant, you have a straight line. So when you're finding your resistance, you use that straight part of the graph. Another point you can do now is take additional points, use the gradient, and to measure the temperature, use the digital thermometer. That's the end of question 2, and so I'll hand you over to Mr. Collins and Mr. Baker.